Hi friends, so welcome again. We will discuss chart OCR data extraction from charts images by a deep hybrid network, deep hybrid framework. This paper is proposed by Lu et al. In WACV 2021 and so before that we have seen that for data extraction there were two papers, revision and a system for understanding image infographics and its application. So those two papers, both approaches were relied on complicated human defined rules, so that was not robust. The accuracy of chart component detection can be improved without using these kind of complicated rules, so that we have seen in last video. So here, for to cope up those previous challenges, previous limitation, Liu had proposed paper in CVPR 2019 on data extraction from chart by a single deep neural network. So that was based on faster RCN and object detection model, and there was a great improvement of time efficiency, but there were also some limitations. So that limitation was the performance on images if downloaded from internet is worse, since it includes more variations. So also it is challenging to cope up with small objects by using the single deep neural network. Also, this data extraction from chart image is a single deep neural network is only work for a bar chart and pie chart. So the if it comes to line chart, so this cannot generalize for all type of chart, because the bounding box information detection on bar chart cannot be adapted to other chart types like line chart. Also, some intermediate result like the data range and plot area information cannot be learned with this deep method. So finally, to cope up these challenges, what it does, it combines the advantages of deep learning on rule-based method for a chart data extraction task for a bar chart, line chart, and pie chart. So advantages, one advantage of doing that is it is also working for line chart, because previous method fell for line chart. It used a fully annotated chart dataset with 400K Excel chart images for training of deep learning model. So, what this chart OCR are doing, by given an image of chart, it is giving a semi-structured data table. So its methodology is saying that first it because it is based on both human defined rules, rule based method, and deep learning method. So uh, this let's first find out the common information extraction. Then it find out data range extraction with a type specific chart object detection, and then finally it extract the chart data. But for doing that, first information extraction find aims to detect the key point and the data type. So what is key point? Key point method output the semantically important keys. That what are the semantically important key point of target compound. So instead of generating the bounding box directly, uh, for bar chart, if we talk about key points, so for bar chart the key point are top left, and here you can see top left and bottom right, corners of each separate bar. And for line chart, the key point is the pivot point on the line. For a pie chart, then key point are the center point plus the intersection point on the arc, that help to segment the chart into multiple sectors. So that is key point for that. So finding out this in this phase, it find out the key points top left and right bottom right for this bar chart. So Once it has done for finding out of this key point detection, then it goes to data range extraction. So output of this key point detection network is a probability map that highlight the pixel in key point detection. So this pixel highlighting feature map created for this probability map created for this. Then data range extraction helps to convert the detected key points from image space to numerical readings. And type specific chart object tells which type of object is after detection. And then by using both this data range extraction is infer the range of data that the chart represent, and type specific focus on extracting the chart object. So this type of specific basically do the extraction based on the type specific, like it is a bar chart or line chart or bar chart. Then it convert into a semi-structured table, all the information extracted from this. uh, More so here this approach, common information extraction approach, is quite interesting. So if we see that, this common information extraction network uses a hourglass network to provide the pixel level probability map of the key point location for these key point location. So what happens? Corner pooling applied on the penultimate layer of key point detection branch to increase the receptive field along the horizontal and vertical field. So here also it use convolution for to better localize key point location, and with converting that into one dimension vector. So finally uh, find out the key point predictions and its type classification. So for this type classification, the last layer means add intermediate feature vector to fully connected layer to predict chart type. So this is a lot of improvement over previous approaches discussed in the field of data extraction from chart images. But with accuracy of chart OCR is with bar is 0.919 and with pi 0.918, with line 0.962 percentage. So chart OCR has better performance than both pure rule-based method discussed in first slide and traditional deep end-to-end method that we discussed right before the slide. So in future, they can expand the limit for other chart type, like for bar chart, pie chart, and line chart. So limit can be expanded to other chart. The data annotated in this also can be used for further research on chart understanding. So this is about data extraction of chart images. Thank you so much for listening me.